Hello everyone and welcome back to the channel. In today's Go tutorial, we will be discussing about one of Go's predefined data types, which is called a map. So what is a map? Well, we can see here it says that a map is a data structure which consists of a set of keys and certain data which is associated with those keys. As we can see in the figure on the right, we have a certain set of keys which are 1, 2, 3, and 4. And we have some data associated with each of these keys. So you can see that the data D is associated with the key 1, B with the key 2, C with 3, and A with 4. And what are the kind of operations that can be performed on a map? Well, we can add key value pairs to a map. We can delete key value pairs from a map. And we can also modify the value associated with a certain key. Apart from that, we can get the length of a map, we can iterate over a map, and so on. So let us see the working of a map collection in Go. Alright, we are back at the Go playground, and in the interest of time, I have written a few lines of code here. So here we can see that I am using the shorthand notation to declare a map which maps values which are of type string into values of type integer. And the empty curly braces means that I am not giving the map any key value pairs during the time of initialization. Next, I'm trying to print the value and the type of the map sales. So if I go ahead and hit run, we can see that our value is just an empty map, and the type of the map is a map which maps keys of type string into values of type integer. So just to repeat this one more time, sales is a map in which the keys can be of type string and the values can be of type integer. So what I will be doing next is I will be populating some values in the form of monthly sales in this map. Suppose I say in Jan we had 1000 and in Feb we had, sorry about that, in Feb we had 5000. And then if I go ahead and run this, okay, we can see that now our map has a certain set of values. Feb is mapped to 5000 and Jan is mapped to 1000, and the type remains the same. Now, before we head further, note one thing very carefully. I cannot get rid of this extra comma at the end of the final key value pair. As you might know, this works in other languages, but it will not work in Go. Now, why the designers took this decision, well, I am not aware of that at this point of time. But as soon as I get to know, I will be pinning a comment in the comment section below, so you can probably check it out later on. Another very important thing that we should always keep in mind while declaring a map in Go is that the type that we choose for the keys of a map in Go should be able to be compared for equality. And if we cannot compare a data type for equality, then it cannot be a key in a map. So regarding that, I will simply put a comment down below. So here it says the same thing. Data types of keys in a map should be able to be tested or compared for equality. So that means that the keys can be booleans, ints, floats. It can be structs. We will see structs later. Arrays. We've already seen arrays, strings, pointer, interfaces, and channels. We will see these data types later on, and etc. It can be user-defined data types and so on. But they cannot be slices, other maps, or functions because these three data types cannot be compared in Go for equality. Let me in fact try to show you an example for the same. So suppose I declare a map here in which the key types is array. Remember, since we are giving the length here, so this means that the square bracket 3 int represents an array and the value type is string. If I try to run this, it compiles and doesn't give me an error. But if I say that the key type of this map should be a slice, we got rid of the length, so this becomes a slice of type integer. If I try to run this, it won't compile because it says invalid map key type of slice of int. Okay, so I'll get rid of this and I'll show you another way in which we can declare a map in Go, which is via the make function. Actually, let me get rid of this as well. And then I say make, and then I specify the type of the map that I want. So again, let it be a map from string to integer. If I go ahead and run this, so it tells me that M is again an empty map and its type is a map mapping string values to integers. Now, this line is something very similar to just creating a map with the literal syntax, such as let's say M1 and then saying map of string to integer and giving an empty initializer list. There's basically not much difference here. Okay, then we will get rid of all of this code and let us next try to access the values present within our map. Okay, so to be able to access values from a map, we simply give square brackets in front of the name of the map, and then we specify the key for which we want to access the value. So in this case, if I say Jan, and let me say Jan here as well, if I go ahead and run this, okay, we see that the value in the map against the key of Jan is 1000 and its type of integer. So this is absolutely as we'd expect. So I feel that the syntax is pretty straightforward and fairly commonly used. We do this in C++, we do this in Python, and I feel that this is any day better than Java's hash maps get and set. Okay, next, let us try to add one more key within our map and then let us try to print it as well. So suppose I say sales in March rose to 10,000. Then I can copy this, print it here and replace the Jan with a March and run this. So we can see that the value gets added in the map and here we are able to access it. In fact, let me also print the map so we can all see that the map has been modified. I'll get rid of the key from here as well as here. If I run this, we can see that after line number 17, our map contains 3 keys, whereas it was containing 2 keys previously. Now let us suppose I want to update the value against a certain key in the map. Suppose the sales in March were wrongly calculated and they turned out to be say 9,000. So I can say sales of March equal 9,000 and let us see what happens. Okay, we got this extra curly bracket somehow. Let's run this code. And we see that the value against the key of March has been updated. Okay, so what do I do if I want to remove a particular key, say in this case MAR, completely from my map? So I can go ahead and use the delete function that Go provides me. I would say delete sales and then I can provide the key that I want to delete from the map. I'll actually get rid of this because this is quite redundant at this point of time and for a reason we'll see a little later. I'll comment out this line as well. If I go ahead and run this code, okay, we can see here from line number 18 that our map contains 3 keys, whereas on line number 22, it contains only 2 keys and the key March is gone. We can also see that previously that key of March had a value of 10,000 in our map. Now, what happens if I still had this print statement? So if I go ahead and run this code, we see that the key of March has been deleted from our map, but we are still getting a value of 0 when we try to access that key from our map. Well, that is just the way maps work in Go. If at any point of time I want to access a key within a map which is actually not present in the map, I will be provided with a 0 value and the value of the 0 value depends on the type of values that this map is capable of holding. So here we see that we get a value of 0, 0.0 if this map had values or was declared to hold values of type float 64 instead of integers, then we would get a value which is of type float 64. And just to show you, I can replace the int with the float 64. I can go ahead and click run, and I can see that we still get a value of 0 when we try to access the key of MAR March. And the type this time is float 64. Okay, but this isn't that great, right? I mean, what would we do if the map was actually having values which also correspond to the 0 values of the type supplied here? We'd actually be in a very big fix, but let us see how we can handle such cases in Go. Okay, so I cleaned up the code a little and we are still accessing a value which is not present within the map. And what we are going to see next is Go's comma OK syntax for accessing values within a map. Suppose I want to access again this value of sales in December, but DEC is not a key in my map. So what I can actually do is I can declare a variable sales in December, and then I can also declare another variable after a comma, and let me call it OK. You can actually call it anything, but generally by convention we call it OK, and then I can try to access the value of sales. All right, so I'll go ahead and print sales in December in this line, and then I will also print the value of OK in the next line. Just give me a minute while I make these changes for you. I go ahead and run this, and I see that the value of OK is false and its type is boolean, and sales in December has a value of 0 and its type is float 64. Okay, so what is going on here? So it's pretty evident, right? When we try to access a certain key in a map, we are being returned with two things. The first one being either the value if that key is found in the map, or a 0 value if that key is not found in the map. And the second one being a true or a false depending on whether that key is found in the map or not. So if I make this Jan instead of December, and it'll keep bothering me if I don't change this or the variable name as well. So if I go ahead and run this, you can see that the value of OK is now true because we have a key of Jan present in our map. Also note the fact that it is absolutely not necessary to store the second written value. If I comment this as well, we could absolutely ignore the second written value. So we can see that our program works correctly. But what happens when we want to actually ignore the first written value and use the second written value? Or you can say that what happens if we just want to check whether a key is present in a map and we actually are not bothered about what is the value corresponding to that key in the map. How do we go about handling that situation? Well, we can simply start using an underscore instead of the variable name. And as you all know that an underscore in Go is used to simply write values which we will not be using further down in our program. So to run this, I'll actually have to get rid of this line. And if I go ahead and run this, we see that the key of Jan is present in our map. But what happens if I say DEC? We can see that the key DEC is not present in our map. The next thing is getting the number of keys in a map or the length of a map. So for that, we have the len function as we have in arrays and slices. So if I just say len of sales, okay, I need to get rid of this as well. I run this, and we can see that the length of the map is 2, which means it has 2 key value pairs. And obviously the type of length, which is 2, is an integer. So it says type is integer. Okay, so the last thing to see here today is that maps in Go are passed by reference and not by value. Again, hear it, maps in Go are passed by reference and not by value. So I have my map here, sales. Suppose I declare another map which is called a sales ref, and I say that it should be equal to sales. And then I simply go ahead and print sales ref. And we see that both of our maps look similar. And what I'll do next is I will simply delete the key of Jan from this map, and in the next line I will print both the maps, sales ref as well as sales. So if I run this program, we can see that the output from line number 15 shows us that the map sales contains two keys. Then what do we do next? We assign we assign sales to sales ref, and we can see that sales ref has the exact contents as sales. Next, we deleted the key Jan from sales ref, but we did not delete it from the map called sales. So if we print sales ref, it is obvious that we do not find that key January or Jan in sales ref map. But as you can see that when we print the map called sales, we see that the key Jan is missing from the sales map as well. So what this shows us is that when we assign a map to an other variable in Go, or suppose we pass maps around in functions and all, maps will always be passed or copied by reference and not by value, which means that changes made through one of the variables will start reflecting in the other variables as well, because all of the variables are essentially working on the same underlying data structure or the same map in the memory. Next, we see a very important and a very commonly used use case along with maps, which is iterating over the contents of a map. To do that, we will be making use of Go's for range loop. So let me show you. I say for, then I declare two variables k to hold the key and v to hold the value. Then I say colon equal to range over our map, which is named in this case as sales. I could go inside and say fmt dot print ln and then specify k as well as v, meaning the key and the value. In this for range loop, the first variable will be storing the key and the second variable will be storing the value. So when I try to run this, we can see that okay, we have two rows of results: Jan 1000, the key and the value, and Feb and 5000, the key and the value here. Okay, so I could actually get rid of the value, and I could just iterate over the keys. Okay, we see we have two keys, Feb and Jan. Next, we could actually use the key and the map itself to get the value. So I say k, and so I say fmt.println k and sales at k, and then we try to run this. We see that we get the same results that we were previously getting. Now, what if I just want to print the values inside my map and I'm not concerned with the keys in this case? To do that, we'll make use of the underscore operator for the first value, which means that our keys will not be able to be read, and then we will give a second variable, let me call it v. Next, I will simply print the value of v. If I go ahead and run this, yes, we see 1000 and 5000 getting printed. So that is the way of using for range loops over maps in Go. So that brings us to the end of our discussion for today. Let us quickly see what are the things that we learned today about maps in Go. We learned what is a map. A map is simply a key value pair type data structure. How to create a map, we saw how to create it using the literal syntax. We also saw how to use the make function to create a map. What are the valid keys in a map? Any keys that can be compared for equality, or any data type, or keys of any data type which can be compared for equality can be keys in a map in Go. We saw how to add, access, update, and delete values from a map. We also saw how do we check for missing keys in a map. We saw how to check the length of a map, and at the end, we saw that maps are always passed by reference. Besides that, all of the code that we saw today has been updated in this GitHub repository, AE Dorado /learning Go, and it has some helpful comments which will also help you revise ORA maps in Go and so on. So please do check it out. And lastly, before you go, if you found the content of the video helpful, please do hit the like button. If you find the content of my channel helpful, please click subscribe. Tell me in the comments below also what other things you would like me to make tutorials on. Hit the bell icon to never miss any new updates. And like always, thanks a lot for watching, and I'll see you very soon in a brand new tutorial.